access and very easy to understand for the new freshers. So why? Because if I just stay, you can just drag and drop the devices and you can connect, easy connections and easy logins. Cisco Packet Tracer is very easy. But it is a limited. Many of the like advanced routing things and all, it's not able to perform in the Cisco Packet Tracer. Okay, done.
Yeah. Yeah. Yeah.
And I was asking you to search for the price of new router, new switches, right?
It is showing
Hmm.
starting price is $19,000 US dollars.
Oh, convert to Indian rupee.
1 second. One crore 79 lakh. It is showing.
Hmm?
Is correct.
One second. Can go for Cisco router. Cisco.com. Yeah. Can you see Catalyst C8500 router? If you just click on that, it will tell you all the specifications of that and also in the detail. So I want to check the cost of this. You take Control C. Price. It's not showing visible here, right? Cost is not visible here.
In Google, it's showing 135,000, 1,35,000.
Hmm. Okay, let me go for ChatGPT only. This
Eight
is
8,200 series cycle.
uh-huh. It's a 8500 series router. What is the cost? 70 lakh 68,643.
643. Yeah.
Yeah, why we are using simulation tools? What is the reason we are using simulation tools? Can I afford that? Can a company afford multiple, suppose 8500 series, 9000 series? Huh? All this, is it possible to invest huge money for practical
No,
purpose? No, for real
no,
time,
it's
if there is
not.
necessary, the upgradations, they can do it. But in real time, for small companies or like a medium company, they'll think most of the time for investing on the devices, right?
Yeah.
So that is why we have a simulation applications to work on that, and you need to check what is the behavior of those routers. So what are the things, what are the features of that, for what it supports, all these things. If I can't purchase the new router or refurbished router, and I cannot do those practices, right?
Yeah.
Is it it's not at all possible. That is why we
Yes.
have a simulations tools. So it is very easy to deploy. We have to download and we have to install it, and you have to open, simply drag and drop the devices and do practices as you do in the real time. Okay.
Yeah.
Yeah. So next thing I was telling you about the GNS3. GNS3 right now I have not installed. I'll show you when it was installed. EVNG is there. I will show you how it is going to work. Okay.
Yes.
Yeah. So first of all, the requirement for the EVNG. Let him join. If he join, let me know. Okay.
Okay.
Requirement, you have to download. It's a free download for Mac, for Windows and all. You can download it on the EVNG website. So download the EVNG Community Edition. EVNG Community Edition. We have Community Edition and Pro Edition. Pro Edition, it is a paid, but we have to download it the Community Edition. Okay. And again,
Yeah.
we need a WinSCP. We have to download the WinSCP. And on also we have a iOS files which I need to which I have to add it on the things, like in Cisco packet tracer, everything is loaded. All iOS has been loaded into that. So easy, I will deploy and I will work on that. But here it's not like that in EVNG. Okay. And also we need VM workstation. VM workstation. And the capacity, you should have at least i5 processor, i5 processor, 2 to 4 crore, 4 core CPUs. If you there, it will be good. And also you should have RAM. RAM at least 8 GB. It's not for normal installation. 8 GB is not must and should. If you're having 2 to 4 GB, that is also sufficient for normal installation. Suppose in case if you're working more in the further classes, you need to add on the memory. Okay. For normal installation, you can go with 2. Suppose if you have more, you can add it 4. Okay. So this is the basic thing. So, and what we have to do. So the steps is, have you worked on VM workstation any days?
No, no.
See, this is a VM workstation. You can download it through the Google. And also in and the EVNG website is also available. So this is the VMware workstation application. Once you download and install, it will get open. Here we have a create new virtual machine option. So how, what do you mean by VM workstation? Any idea? Any idea? Do you have any idea? Yes or no?
No, no, no.
No idea. See, we have in VMware is nothing but we have a Hyper-V. Have you heard? Are you aware of Hyper-V? Have you aware of Hyper-V? Okay, have you aware of virtualization? Aware on virtualization, Junaid? Yes or no?
Yeah. What virtualization? I know.
Yeah, so virtualization, we have two types, type 1 virtualization and type 2 virtualization. So right now, what we are using? We are using a type 2 virtualization. What do you mean by that? We have an operating system. On the operating system, I am installing one application, that is a VM workstation application I am installing, right? Yes? This is called type 2
Yes.
virtualization. Then what is type 1 virtualization? Type 1 virtualization is on the bare metal itself. I'm going to run the virtualization. That is a bare metal installation. That is comes under type 1. Okay.
Yeah.
So whatever I'm using here, it's a type 2 virtualization. 1 second. Okay. So what you can do, see, if I want to, okay, let me say, in this topology, how many machines I have? How many physical machines I have?
4.
This one. 4 machines I have and one switch I have. Just imagine in a real time, I want to work means, can you able to invest this 4 PCs and one switch? Is it possible for you? Hmm? For me or for any of us? Is it possible? No, right?
No, no.
We cannot go and just take for the I don't have any use. Just for the practice purpose, I have to go and invest. Let me take one desktop is about 20 to 25,000 for our usage. Okay. So altogether we get here 1 lakh itself. And coming to switch, so refurbished switch itself, you will be getting like 70, 80,000 like that. Okay. So it's
Yeah.
not possible in a real time. We cannot do. In the same way, suppose I wanted to work on one machine, I wanted to work on Linux operating system. Other machine, I have to work on Mac operating system. On the other machine, I want to work on Windows Server operating system. Another machine I want to work on Windows operating system. So I want to work, I want to practice on all the machine. It is not possible for me to purchase real devices and to work, right? So what
Mhm.
I can do here, this VM workstation helps me to install the virtual machines and I can work it on. Suppose let me say I have already here installed with Windows Server. So I have already installed this with. If I power on, I can work with Windows Server operating system. In the same way, I have EVNG. If I power on, I can work with EVNG here. Okay, like that.
Yeah.
So I can create a new, like Windows 10 machine, I can install Windows Server, I can install Ubuntu, Linux, whatever the operating system I have to work on. I can work it on this through this VM workstation. Clear? This is
Yeah.
a type 2 virtualization. So we were discussing on the EVNG. So let me go for EVNG and power on this virtualization. You can see memory I have given 8 GB processor. Okay, 8 processor it has taken. I just let it down for 2. Click on OK. Power on. EVE stands for Emulated Virtual Environment. NG stands for Next Generation. Okay.
Yeah.
So there is a process to install the EVNG. So whenever in the further classes I require, it will be discussed with you. So once I turned on, it will provide some IP address here. Can you see here? 192.168.29.34. This
Mm.
IP address, I have to use it in the web portal. So here I'm using that 192.168.29.34 is the IP. 34 is the IP, and by default admin is the Admin and Eve is the password. So let me log out and I'll show you. See, username is admin and the password is Eve. And native console, HTML5 console, both we have. You can go with HTML5 console. So you can click on sign in. Okay, I had signed in. So let me delete these routers. Now you can see as compare with Cisco Packet Tracer. See Cisco Packet Tracer, how easy it is to work.
Yeah.
I want to deploy with switch. I want to use with the desktops. I had easily done, right? Is it possible here?
Yes.
Same topology, I'll design it here. So now I have to work on with this. So right click on any of the space, empty space. You can go for a node. So once you go for a node, see everything is graded out, right? Here.
Yes.
See the highlighted one is which is having a OS. iOS is installed for that. That is again another procedure. It will be shared in the further classes. Again, see, this is also iOS installed to that. So that is why it is highlighted. iOS 375, iOS 720 router. We have VIOS router, VIOS switch. So I'll take one switch. See, number of nodes to add, one. If I give two, it will add with two. And image, so image file it is added. So image is this one. So name, and here you can change the icon as well. So see here, we have icons. I'll go with switch.png. So let me go. So CPU limit 1, RAM, Ethernet, everything. Like it is editable, but in Cisco, this option is not there. But this is going to, for advanced versions of networking configurations and all, I can do practice in the simulation. Okay.
Yes.
Save. So I had taken two switches here. And I need to go again for a node. I'll scroll down. I have an option called VPC, virtual PC. Click on that. I want 8 virtual PCs. Let me take 8 virtual PCs. Desktop, it is asking. I want like this desktop. You can go with that image. So you can change whatever you want. If you want laptop, you can take the laptop like that. So click on save. See, I got a VPC. So VPC3, VPC4, VPC5, and VPC6. Just delete selected. I'll go with another VPC image. Go to node, right click, go to VPC5. So let it be desktop. I need 4. Click on 4, click on save. See, this is the another image. Okay. So now I have to perform simple lab. Same thing what in the Cisco packet tracer I shown. Same thing I'm going to do it. So here, let me take this and connect to this switch Ethernet 0. Ethernet 0, save. Again, take this one and connect to the switch. So I hope, yeah, gig 0/1 is there. Gig 0/0/1. Okay, fine. Connect to this and save for gig 0/2. Okay, here we have. Okay, gig 0/2, save. And take this, connect to gig 0/3 and save. You have to repeat. Which is easy? This is easy or Cisco packet tracer is easy?
Cisco is better.
Yeah. Gig 0/0, save, connect from here and gig 0/1. Take this, connect here for 0/2, and here take this and connect and save. I have taken two different networks simply for working purpose. Cisco packet tracer you have already explored, right? Explored
Yeah.
or not? Kind of you had explored, I think.
Yeah.
Yeah. So let me rename this. Edit option you can go. So ID it's showing 3. Can I edit it or I have to go for text? Text you can go. So 192.168.1.1 I'll give and save. This IP I'm using. Again, I'll take the text. Eighteen 192.168.1.2. Save. This is the one. $16 or $18 we take? $18, huh?
18.
92168.1.1. We can't save. One nine two one sixty eight 1.3. Two dot one I'll give. Okay. Done.
Yeah. Yeah.
So now what is the next step? I have to assign IP inside, right?
Yes.
Inside of this machine. In Cisco Packet Tracer, we are double click on the machine. So here it opens and I'm going to use this desktop portion and I'm going to provide the IP address. This was the procedure in the Cisco Packet Tracer, right?
Yeah.
Whereas here, if you double click, it is asking you to start. Directly, it's not a direct plug and play like in Cisco Packet Tracer. We have to start the devices. So I just select all the machines all together and say start selected. Here you can see the notification. So the PCs are going to be started. It's going to provide you the notification. Okay. See, it's turned on. Color is changed. Observed?
Yeah. Yeah.
Yeah. Now this is also, it was a gray color, so it is turned on to blue, right? This switch and this switch, both the switches as well. Now, if I right click, stop option I have, wipe I have, export like that. Suppose let me say double click, it is going to open with the another HTML console. Okay, now wait. See, it's opened with what? It's asking with the CLI, right?
Yeah.
IP add invalid IP address. I think I have forgotten. Show IP. Yeah? Show IP command. What it is showing? Name of the PC VPC S1. IP is not assigned. Gateway is not assigned. So nothing is assigned. MAC is this is the MAC address. So I have to assign the IP address. For that, what I have to do? We have a command. Go to enable. I've forgotten 1 second. Uh, I'm using VPC5, right? This is not a uh, IP add. It's still invalid. Okay, put question mark. IP and the question mark. IP auto, IP DHCP, IP DNS, IP domain. Assign manual IP. Show ARP. Is it? ARP table is empty. Okay. Suppose let me say, okay, I'll use this command IP 192.168.1.1 and followed by subnet mark. Directly I will assign. Let me check. Checking that. Okay, it's taking. So this is the command to IP, add the IP address. Okay. So here you can use IP followed by 192.168.1.1 is the address. You can add it. Following me?
Yeah, yeah.
Okay. Show IP, I say. Okay. Is it taken? IP mask?
Yeah.
And /24 it is taken. Why it is taken /24? Have we discussed in IP addressing about this one? What do you
CRDI
mean by slash
notation.
24? 24,
CRDI notations.
24 ones. That means 3 octet is for network bits, right?
Yeah, yeah.
3 octet is for network bit. So I have assigned IP address manually to this. Again, I'll go back to this. This is one. EV topology. Go to this machine, double click to that. This is for VPC3. Okay, what is the command? Show IP is the command for checking the IP address and assigning the IP followed by the IP address and the subnet mark 192.168.1.2. Let me say /24. Will it take or not? Instead of giving 255.255.255. Yes, of course it has taken.
Yeah.
I'll give the command show IP. Gateway not assigned. Okay, fine. I don't need a good. Got it?
Yeah, yeah.
Here it is taken gateway for this. Huh? So I'll just change that IP 192.168.1.1/24. Let's see, show IP. Yeah, that gateway was wrong. I had removed that one and I had given this one. 1.1 is over. 1.2. This machine IP is what? 1.2. Right?
Yeah.
Again, come to
Yes, yes.
1.3. You can give show IP. Nothing is assigned. You can add the IP address 192.168.1.3/24. Enter. Again, you can give show IP. 1.3 is assigned. Come back here. Go to 1.4. Again, you can repeat the commands for the other PC. IP 192.168.1.4, that is /24. And again, you can give show IP. Have you assigned or not? Done?
Yeah.
If I give a command show ARP table is empty because packets are not exchanged. What is ARP? Address resolution protocol, and RARP is a reverse address resolution protocol. These are the two protocols which is available in the layer 3 and layer 2. In between of that, layer 3 and layer 2, the RARP supports for layer 3, ARP supports for layer 2. Got it?
Yeah.
Got it? Okay. So what is ARP? In the next class, I'm going to, sorry, in further, if he had if he had joined today, I thought let me complete off that one. If I start also again, I have to recall for you. That is why I'm taking another useful class. Okay. Is
Yeah,
that
no
okay
problem.
for you?
Yeah,
Yeah.
fine.
Yeah, okay. Now I wanted to check the connectivity between these, whether these are pinging or not. So how to check? I go to 1.1 machine. I wanted to start ping 192.168.1.2. I'll check. Getting a reply? Yes,
Yes.
I'm
Yeah,
getting a
yeah.
reply. I check for 1.3. How many machines I have? 1 plus
4.
3, right? Yeah, total 4. 1 plus 3. So source is what? Source is 1.1. Who is the destination? Destination is the target
1 not.
machines. Yeah, all 1.2 is destination, 1.3 is destination, 1.4. See, as a network administrator or system administrator, let you assume here I have for this network 250 machines. Will you go and keep on, will you do this task? Ping 1.4, ping 1.5, ping 1.6. Will you do that? Instead of that, he used the broadcast address. What is the broadcast address for this network? 192.168.1.255, which we broadcast as address cannot assign for any of the hosts, right?
Yeah.
That's why Why? Because it is a reserved IP address. Let me ping with that 1.255. See, who are alive in the network that are going to be, it's telling 1.255 is not reachable. Okay, fine. No gateway found. 1.255 only I have to give. One second. Has to take. I don't know why it's not taking. Okay, I'll show that in the Cisco packet tracer. Leave it. Okay. So same thing. Now
Yeah.
you can give show ARP. What is there? ARP table is showing the MAC address of the targeted machine which I was targeted. I was targeted for 1.4 in the previous. So it is showing me 1.4 MAC address of this is this. So ARP and RARP are the both protocol which works with network 3 and layer 3 and the layer 2 in between of that. So what is the use of ARP and RARP? It is going to convert IP to MAC, MAC to IP. Okay.
Yeah.
If it's for our network layer IP, no, but it does not know the MAC address where to send the packet. So what it will do, it is going to search for the ARP address. So ARP address is a MAC address. RARP is a IP address. So IP address knowing, but it is searching for the MAC address. So it will do bidirection. So in the see flow, the packets are flowing from, if you take OSI model from layer 7 to layer 1 again from that is from the source. At the destination side, it is taking the packets from lower layers to the upper layers, right? Upper layers also. So here
Yes.
when it is going packet going to the upper layer, layer 2 know only the MAC address, but it don't know the IP address of the machine. So IRP helps here to find out the IP address of the machine. So it's suppose in between to identify the MAC and the IP. Clear?
Yeah.
So this is how we can do the configurations. We have to attach the VPCs, deploy PCCs, and switch. If I want to go, let me log into switch. So this is a switch. So enable the command I give show IP interface brief. If I give, so how many interfaces are there, it will show you. Suppose if I give question mark, so these are the things I can work in the switch. I wanted to check the MAC table here. So for that, show MAC address. Yeah, space you should provide. Show MAC address table. So what are the giga 0/0? It's a MAC address of this. Giga 0/1, the machine MAC address is this. 0/2, that machine MAC address is this. 0/3, that machine MAC address is this. It is going to show the MAC table. Okay. In the
Yes.
switch. Okay. So now I wanted to close the lab, you can close, but you have to turn off the power of them before closing the tab. Same thing here, you can repeat it. So power off all the machines now. Stop selected. And say close lab. So this is what the lab we performed. So this is the one. So to open, actually previously I thought to do for OSPF. Uh, Now I had changed this one, right? So here you should go for open. The same topology it gets open and I have to turn on. I have to start the work. Okay. This is how we work in the
Yeah.
EVNG. How you feel about EVNG? What is your feeling about EVNG?
It is full different of from Cisco packet tracer.
Yeah, completely different from Cisco packet tracer. So here it is very easy to do the tasks, right?
Yes.
So there it is little tougher until you get practice. Okay, so let me go with this. In this topology, you can see this is a switch and this is a hub, right? This is a hub. So I have assigned the IP addresses for the PCs. Here also I have assigned the IP addresses for the PCs. Both the topology is ready with the IP addresses assigned to the machines. Now, the thing is, I'll go in the simulation mode. I wanted to ping from one machine to the other machine. Okay, done.
Yes.
So I want you to check what is the behavior of the hub and what is the behavior of the switch, how hub is differ from the switch, and why switch is better than the hub. These are the things you're going to observe. Got it?
Yeah.
Okay. So we have real time and the simulation. What is the difference of real time and the simulation? The real time, so it takes less memory and I can send the packets through the CLI and I can check out the ping. For example, the like go to the command prompt ping followed by the destination IP, you get a reply. That is how we can identify or we can focus on that and we can work on that. Here also, for switch, I go to CLI and I will click and I will go into the CLI. Then I will work like that. Whereas coming to the simulation, how it is going to be differ. Keep on simulation mode. We have show all or none option here. Edit filters, show all or none. See, show all or first you should go with edit filters, then show all or none. It will be selected with all. Again, you click, it will uncheck with all. Again, you click check with all, uncheck with all. So for now, for communication, okay, this is the basic lab I'm doing. I'm not working on the DNS. I'm not working on BGP, DHCP, EAGRP. These are all the protocols. I'm not going to work on this. Right now, I need only with the ARP. ARP, you got to know what is the use of that. So that is a mandatory protocol. ICMP also, you know, ping uses a ICMP protocol to send a echo request and it will receive a echo reply, right? So these are the two
Yeah.
protocols I will check. Why you are not going to check with this all? What is the problem if I check with this all? Simply it is going to use the memory and it will just do the delay. All the packets keep on sending. Okay,
Yeah.
I'll close this one. So now you can observe I'm in the work hub. I'm in the hub network. That means my networking device here, hub works in the layer 1 device. Okay. What is the features of hub? What is the features of hub? Hub works in a layer 1 device. It broadcasts the packets. Okay, layer 1 means which one? Which layer? Physical layer, right? What hub will do? Hub receives the electric signal. It copies the signal to all ports. Like if I start to send the information from 2.1, so I wanted to send, it keep on sending the broadcast, it keep on sending the messages to all the machines. That means it will simply broadcast the packets to all the machines irrespectively. Okay. So
Yeah.
that what is the thing? So layer 2 means what? Yeah, is a frame or it is a um, what is the PDU of layer 2? What is the PDU of layer 2? Can
Frames,
you?
I think. Frames, I think.
Yeah. See, for layer 4, What is the PDU?
Layer 4.
Yeah, for layer 3, for layer 2, and layer 1. Layer 1, it is bits, binary digits. Bits stand for binary digits. Layer 2, it is frames. For layer 3,
it is packets.
yes, packets. Here, for layer 4,
4 segments.
segments. This is what. So when we are talking about the layer 4, we will talk on the segments. Layer 3, it means it is a packets. When I'm talking about the router, that means it is a packet, right? When I'm talking about the switch, that means it is a frames. And I'm talking about the hub, that means it is a layer 1, which is going to bits means what? Binary digits. Binary digits means what? Electrical signal, zeros or ones, right? Zeros or ones. Yes or no?
Yes, yes.
Okay. So now, whenever the frame, suppose let me say here, I wanted to, this is the source. And here I want to ping to this one. This is my destination. I am sending the frame from 2.1 user. 2.1 user is sending the frame to 2.4. Who should receive? 2.4 only it should receive. Suppose if the frame is sending 2.2 as well and 2.3, what is the problem? What is the problem? Will I get problem or not? In our case, just simply think in this way. In our case, how many machines are there? 4 machines.
4.
Do you think in real time for a company only 4 employees will be there?
No.
No. Can I say 200 to 500 employees?
Yeah.
Okay. Okay. Give me an answer. Suppose, see, I have a lunchtime from 1 to 2, 1 p.m. to 2 p.m. All the 500 employees going for doing lunch to the hotel. So how congested here? Is it congested?
Yeah.
If they are going all the 500 employees to the hotel for the dining hall, is it congested or not?
Yeah.
It is congested. Suppose, let me say, for 1 to 110, let 50 people go, and 1 to, sorry, 120, let I'll give 20 minutes. 120 to 140, some 100 people, let them go. Like that, if they decide and if they go, so traffic will be controlled or not?
Yeah, controlled.
Yeah, understand here the same thing. So whenever the packet frames are generated, so the message, the frames are going to send through this hub. For hub, hub is going to receive that frame, not frame, sorry, bits, electrical signal, right? Bits. Hub is going to receive that information, and it is having the, it do broadcast. I say hub is a broadcast device. Hub is a broadcast device. Okay. Why I am telling broadcast device? Instead of sending the information from 2.1 to 2.4, let me say all 500 employees, it is sending the traffic for all the 500 employees. See, 500 minus 1 means 499. Remaining all 499 are going to receive this traffic. Now, what will be the problem to the network? What will be the problem to the network? In a signal, all the 500 vehicles want to move in 180 seconds. Is it possible?
No, it's not possible.
If they try to move within 180 seconds, within the given time, what is the problem occurs? No one can go properly.
Yeah.
Right? Or it may go for accident. Or they will shout on each other. Risky. In the same way here. So if the traffic is more, then the network congestion will be more. We call that as a network congestion. Got it?
Yes.
Okay. So for hub, there is no any MAC address table, and hub is not an intelligent device. Hub is not intelligent device. What do you mean by this intelligence? That means it will not going to maintain any table. So any recordings inside this device, nothing will be there. Whereas in the switch, we have a what is that? It stores MAC address table. Yeah, in the previous I had shown MAC address table information. It was there, right? It stores the
Yeah.
information. That is why I say switch is an intelligence device. Whereas coming to the hub is not at all intelligence device because it will not keep anything in the device. Okay. And I say it is a one collision domain. So that means I was explaining on the network congestion, right? So it is a collision domain. But why still company prefer? Earlier it was preferring, but now no one like they are not using much hub. They use only for the basic purpose like connectivity purpose. They will be using the hub. It is a very cheap and simple to connect. That is the characteristics of the hub. Clear?
Yeah.
So if I ask, will hub learn the MAC address? Yes or no? Will hub learn the MAC address or not? Hub does not learn the MAC address. It is
Happiness.
not intelligence device. If I ask you the question, hub is a single collision domain or multi-collision domain? Hub is a
Single.
single collision domain. Okay. Hub supports
Yeah.
for full duplex or half duplex. Full or half. It supports for half
Half
duplex.
duplex.
What is the performance of hub compared to switch? Fast or slow?
Slow.
Slow. So these are the characters. Do you want me to repeat those points? Do you want me to repeat or shall I go ahead?
No, no, go ahead.
Okay, fine. Okay, now I'll just show you by being on the simulation mat. So here in the below for this file, below of this file, you can see some components here. So you can place a cursor. It will show you this is a PDU. You take this packet, drop it on 2.1. Before that, you can go and check ARP-A is the command here. There it is show ARP. Here, ARP-A. There is no any ARP entries. That means MAC address I have not learned. Okay.
Yeah.
So if you want to see the MAC address, you can check the MAC address as well. Come to physical. So where is that? Config, post Ethernet 0. So this is the MAC address, not this one. Sorry. This is the MAC address. Control C and paste it here. My machine is stuck in. I had turned off VM. Okay, I'm in simulation mode. No, that is why this is the problem. Keep it in real time. Paste this. I'll show you why it is important. This is the MAC address. Go to this machine, come to config, come to fast Ethernet 0. Take this, Control C and paste it. This is the MAC address. You can go and check through the command. ARP entries are there in the machine by issuing the command ARP-A. There is no entry in all the machines. You can check with that. So we'll verify ARP entry is there. ARP-A, nothing is there. Again in this machine, let me verify on the desktop. Go to command prompt ARP-A. Why? Because there no frames are being exchanged here. That is why there is no any ARP entries are obtained, right? Yes or no?
Yes. Yeah.
Okay. Now keep it in the simulation mode. I go for take this PDU. This is a protocol data unit. Insert this packet here and drop it for the destination. I will drop it for 2.2 machine here. This is my destination. Who is my source? 2.1. Who is my destination? 2.2.
2.1. Yeah.
You can open this packet.
2.2.
Yeah, you can open this packet. Layer 3 IP address. Source IP is 2.1. Destination IP is 2.2. This is out layer. Where it is showing? It is showing under the out layer. Okay.
Okay.
Yeah, close it. Open this packet again, green color. That is what? It is having layer 3 information and it is having layer 2 information. One
Layer
packet is
2.
for layer 3 information. The other packet is for layer 2 information. What layer 2 consists of? Layer 2 consists of the MAC address. You can see Ethernet 2 header 0010. Can you see 0010? Where is that? Stuck. I'll open it again. Yeah. 001011AE772C. Which machine MAC address is that?
2.1.
2.1. Did you understand why I copied and pasted MAC address? Okay. For destination, what it is there? FFF. What do you mean by FFF? FFF. MAC address indicate what? All F means what? That is a broadcast. That is a broadcast. That means till right now for this PC to reach the destination, it is not knowing which machine is having the destination MAC. It doesn't know about the destination MAC. It only know about the source IP and the destination IP. Whereas coming and to look into this, there is no source. Only it is having source MAC. There is no destination MAC information. So that is why it is going to send the broadcast message in the network. FFF indicates it is a broadcast message. Clear?
Yeah, it's clear.
Yeah. I'll close that. I'll click on this play control. And I'll pause. Now I had paused. Open this again. Now where this? Hub is a layer 1 device. It receives the information at port is fast Ethernet 0. Right?
Yeah.
And here layer 1 ports, or which are the ports which is added in this? Fast Ethernet I had connected, fast Ethernet 2 I had connected, fast Ethernet 3 I had connected, fast Ethernet 0 I have connected. Fast Ethernet 0 is my source, right?
Yeah.
Fast Ethernet 1, 2, 3, it can be any, in this anything can be my destination. That is to the out layer. What is the information received? That is under the in layer. Got it?
Yeah.
Okay. Now again close this. Play control. What it done? What it done? Everybody received the information. That means it is broadcasted to all. The example I showed. When teacher is talking in the classroom, if okay, let me take the 50 students in the classroom. I am talking to Junaid. All the students who are present in the classroom will listen to teacher and Junaid conversation or not?
Yeah.
Same thing here it is happening. All the machines are listening to that. But who is received the information? Destination machine is informed the information, right? See, this is tick mark, whereas here this is rejecting the packet. Right? Open this. Fortinet receives the frame. Okay, here what it is showing in the layer 2. Ethernet 2 header 0010 AE 1 AE 772C. This machine source MAC, but destination MAC for this it is unknown. Right? Close it. For this also destination MAC is unknown. This is a broadcast destination MAC. Right? Close it. Whereas coming to here, open this, and here you can see the information what it is given. Ethernet 2 header received the MAC address. MAC source MAC is this, and the destination MAC is unknown. ARP packet source is 192.168.2.1. Destination is 2.2. What it is showing here? Ethernet 2 header 005. Can you see the source destination MAC address here? Got updated. Yeah, destination MAC address got and updated, and here it is a source MAC ARP packet. Source IP is received from 2.2, and it is now it is ready to send back. It has to send reply. No, it has to send reply. Now this is the source, and this is the destination. For this packet 2.2, now who is the source? 2.2 is the source. Who is the destination? 2.1 is the destination. I'll play the control again. See, if I play the control again, okay. What happened here? All the machines received the information. These two is again it is rejecting, whereas here this is going to. Now MAC address has been exchanged for both the machines.
Yes.
Now you can go and check. I'll just close this one. Real time. Go to PC. Command prompt R-A, enter. See, what is ARP table? Take down the question. What is ARP table? ARP table present in PC, right? I'm not checking in the hub. I cannot do anything in the hub. It's just simply plug and play. So what is the job of ARP? It will map the IP address to MAC address, right? It will map with IP address and the MAC address. Show ARP you can use, or show IP ARP. In like in Cisco packet tracer ARP-A we have to use. There it is show IP ARP we have to use. So like that. Okay.
Yeah.
So now what you understood in this, you tell me. I'll again start ping. Let me complete and I will ask you the question. You just note down the points, what you have learned and what you have understood. So how good you have understood, I can understand. Okay, I'll go on ping with. So my earlier ping with 2.2, I will ping with 192.168.1.3. Enter. You can keep it in simulation mode and you can play control 1.2.1. Sorry, 1.1 I had given, right? Okay. Who is going to receive? Everybody is rejecting.
Everybody is rejecting, yeah.
Because that IP itself is not there. Right?
Yes.
Yeah. So it is unsuccessful. It should not successful. Let me check what was my ping. Yeah, request timed out. Can you see? Yeah, here into request timed out, right?
Yes.
Yeah, I'll give 2.3 and say enter. Clear? I'll go for this delete and again take this 2.1 to 2.3 play control. You can see here, right side. Stop working. Please save it. Why? What happened? It was not saved only. Gonna. God. It was not saved.
Yeah, directly get back.
Yeah. Again, I have to do. Okay. What are the things? Have you learned anything interesting today? First topic was interesting today. Lab topic.
Yeah, yeah.
Can I continue or we'll wind up for today and we'll continue tomorrow? Let him also join.
Yeah, no problem.
What we'll do?
Yeah, no problem.
Okay, we'll wind up for today and we will
Yeah.
continue it tomorrow. Okay. Okay, then. Thank you.